Hello everyone. In this video we're going to talk about some basic counting principles. So the first is going to be the rule of products, and this basically arises from something that we already know of Cartesian products, namely that the number of elements in a Cartesian product is simply the number of elements in the first set times the number of elements in the second set. So to think about why this is true, let's take an example. Okay, so let's let A be just the set with the numbers 1, 2, and 3, B with the set A, B, C, D. Okay, then what we can do is actually make a table to kind of see what all possible pairs are here. So let the elements of A be the rows, and then let the elements of B be kind of the columns. And so how many things can we pair up? Well, for each row, we multiply it by that number of columns, right? So we have 4 here, we have 4 here, and we have 4 here. And so we have 3 times 4, the number of rows times the number of columns, and that's exactly n of A times n of B. So let's think of a simple example here. So how many possible outcomes if we roll 2 dice? Okay, so in this case, if we roll a single die, right, we would have 6 options for that one. And so here we have basically like 6 rows and 6 columns. And so this is going to be 6 times 6, or 36 total outcomes. So obviously drawing a table gets tedious pretty quickly. You know, even the 6 by 6 table would be a little bit annoying. But if we have more choices, it would become a lot harder, because 3 choices would lead to a 3-dimensional table. And, you know, that's doable, but once you get to 4-dimensional table, I think you're going to have some trouble drawing that. So you really just want to think product of the numbers of choices for each one, okay? So again, let's look at another example. So let's say we flip a coin, roll a die, and draw a card in that order. Then how many outcomes? Well, you would again just multiply, right? These are all independent of each other. We're doing them consecutively. And so it's, you know, we have 2 choices here times 6 choices here, 1 through 6, times, so we'll just assume it's from a single deck of 52, just standard. And so this would be 2 times 6 times 52 total outcomes. And so one other thing that I think is important to talk about here really quickly would be something like picking a pin number with 4 distinct digits. So this gets at limiting your choices after a certain point, right? So you basically want to think we have 4 options here. They're going to be multiplied together. Again, you just want to think of how the rows and columns kind of work, but you're kind of going up in dimensions. But first of all, how many digits are there? Well, we have 0 through 9, so there are 10 possible digits. But here, the key is that these must be distinct. So, you know, you have 10 choices on your first one, but then once that is chosen, that cannot be chosen again. So then you're down to 9, right? Then those 2 can't be used, you're down to 8, and finally you're down to 7. And so this would have 10 times 9 times 8 times 7 total options to get a 4-digit pin number with no repeats. All right, so for your first exercise, I want you to answer this question. How many 4-digit odd numbers can be formed if no digit can be repeated? And so as a hint here, you kind of want to think about 2 things, right? So it's odd, so I would start by thinking about what your last digit should be and then go from there. And since it really must be 4-digit, are you a little bit limited in terms of what you can start with? Okay, so think about those 2 things. So the next basic counting principle is the rule of sums. So we just had products, and this one also comes from something we know, the inclusion-exclusion principle. So we know that the sum of a union is the sum of each part, but we may have double counted, right? And so we remove the intersection. And for us, we're going to start by looking really just at what if they're disjoint? What if these 2 options do not have any overlap? And that would be just the sum of the 2 parts if A intersect B is the empty set, if they don't overlap at all, okay? So let's look at an example of this, and we're actually going to use the rule of products as well here. So we're planning a trip to Vegas. We have 3 direct flights and 2 with layovers on the way there. And we have options from 2 direct flights and 4 with layovers on the way back. And we want to know how many flights total. So how does the rule of sums come in? Well, we really want to think first actually in terms of the multiplication principle, because we're really thinking like our number of options to and then our number of options back from, and so we'll multiply those together, right? Because they're really being paired consecutively. But then we can break down the 2 into 2 different disjoint things, right? So we have the direct plus the layover flights in each case, right? So that's both in the to and the from. And so that's where the sum rule is coming in. So determine the number of flights to that we have options of. Well, it's just 3 direct plus 2 layovers. So we have 5 options here. And from, we have 2 plus 4. We have 6 options. And so it's going to be 5 times 6, or 30 different flight combinations there. So let's look at a bit more complicated example where we're again putting these 2 rules together. Okay, so here we have a 5-digit number. First digit is not a 1. The first 3 digits all must be different. And if the first digit is a 5, the last 2 digits are the same. So clearly the rule of products is coming in from multiplying, the number of choices for each digit. So where does the rule of sums come in? It's going to be this last part, because we have 2 cases. So like case 1 is going to be you start with 5. And then case 2 will be that we don't start with 5. Okay, and so that's how we're naturally seeing this go into 2 groups, and then we'll add up the number of things in case 1 plus the number of things in case 2. Okay, so we've got our 5 digits here, and we know here that the first digit is 5, so we have 1 option. And then the first 3 digits are different. So next we have 9 options because it can't be a 5, and then 8 options because it can't be a 5, and whatever you put in the second digit. And then for the last 2, we know they're the same number. And so, the first one could be any number, but then the next one must be the same. And so we do not have any choice of that last one. It must be exactly whatever our 4th digit was. And so here we have 9 times 8 times 10. So we have 720 options. So then let's look at the second one. So here we're not starting with a 5. So the first digit is also not a 1. So we have 8 options here, right? Not 1 or 5. But then the second digit, it can be anything different. We have no restrictions, and so it's just not whatever we had in the first. It's 9. This is 8 for the same reason as above. And then here, we no longer have an issue of the last 2 digits, right? We just kind of can choose anything we want in this case. It doesn't have to be distinct, and so it's just going to be 10 times 10. And so this turns out to be 57,600 when you multiply these all together. And so overall, we have 58,320 different options because we just add them up, right? 720 plus 57,600. All right, and for your second exercise, I want you to think about how many 3-letter, I put words in quotation marks here because I'm really saying just any combination of letters with 2 consonants and 1 vowel. So for instance, like I would absolutely count ABC. Like that would be an example. It's nonsense, it's not an actual word, but it's got 1 vowel and 2 consonants. So here, right, think about how both rules kind of work together. How can you break into cases thinking about the presence of 1 vowel? All right, and that will be all for this video. So thank you for watching.